Hey guys, so in this video, I'm now going over the second lesson, which is continuing the factoring and solving trinomials, but now we're going to have more steps, so with our multi-step. So again, just that reminder, we talked about this in the first lesson, which is here again, focusing on that standard form, right? So that ax squared, where a is that leading coefficient, b is that middle term, and c here is our constant. And that first step, right, we always want to make sure that we're looking for that GCF. And if it's there, to divide all terms by that GCF. If not, then of course continue with the factoring. And then just like in our previous lesson, once we've gotten that, taken care of the GCF, we can go through and factor. We've got box method. Here you can use the table, or you can use the bottoms up method. And so now let's take a look at our first examples here. So notice how our A is 2, right? A is greater than 1. So do we have a GCF? Well, now actually, yes. If you notice, what is the GCF here between 2, 16, and 30? Well, 2. So I'm going to divide all of those terms by 2, the GCF, the greatest common factor. So now I've got 2 divided, right? Now we factor that out, so I'm going to bring that on the outside. Well, what's 2 divided by 2? 1. So I can just leave it as x squared. So now here, that positive 16 divided by 2 is now going to give us 8. So 8x plus 30 divided by 2, which is now 15. Now we can go through and factor. Notice how our A is equal to 1. So we're going to set up and do the same thing as what we did before. What two numbers multiply to give us 15, right? And add to give us 8, our B, that middle term. So let's see, our two factors, well, 15, that would be, let's say, 5 and 3, right? 5 times 3 is 15. Oh, well, what's 5 plus 3? 8. So that's our two factors. So don't forget the 2, right? That common factor, that's part of our factoring. Then here we've got x plus 5 and x plus 3. Then, of course, you can use box method to check your work. Now, with bottoms up, we would go, well, Ms. Reiner, don't we have to divide now everything by 2? Well, no, because we didn't do bottoms up, right? That was a GCF that we divided out. So let's go to 1b. Notice how, again, our A is greater than 1. So first step, do we have a GCF? Yes, we do. Now this one's a little different though. So what is the GCF between our three values? Well, 3. But notice how we also have something else that they all have in common. What's something else that they have in common? They all have at least one x here. So see how we have 3 x's, 2 x's, and here we have 1 x. So that means I can take 1 x from each of my terms. So our greatest common factor is now actually 3x. So now when I divide that out, here we go. Well, 3 divided by 3 is 1. We started with 3 x's. We're taking out 1x, so now we're left with 2 x's, so x squared. Same thing here. We've got 9 divided by 3, which gives you 3. And then we have 2 x's dividing out 1x, so now you're just left with 1x here. Then here we've got negative 30, right, divided by 3, giving you negative 10. Notice how x and x, they just cancel each other out, so you're just left with that minus 10. Then notice, guys, see how we ended up with our standard form? That is our goal. Now we can go through and solve. Notice how A is 1, so I'm going to set up my table. What numbers multiply to get you not 10, right, but negative 10, and add to get us 3. So let's see, we could have negative 5 and positive 2, right, because they would multiply to get you negative 10. But what do they add to give you? Negative 3, right? So let's switch it up then, if the sign was wrong. So let's say 5 and negative 2. 5 plus negative 2, there will give you your positive 3. So this becomes 3x, then in factored form, x plus 5 times x minus 2. And then, of course, you can use box method to check your work. So go ahead and pause the video here and try 1C on your own. And here we go. So same thing, right? Do we have a GCF? Because I saw A was greater than 1. Yes. So you should have divided all terms by 6. Good. So now here I divide everything by 6. Well, 6 divided by 6 is 1. So it's just x squared. Negative 36 divided by 6, negative 6. And then negative 6x. Then 30 divided by 6 is 5. Now we're back to factoring. Notice how a is just 1. So I'm going to set up my table. Multiply to give us 5 and add to get you b, negative 6. So here in this case, we have the two negatives because two negatives when multiplied make a positive, but when adding still gets you that negative 6. So here, don't forget that GCF, right? So we have 6 times x minus 5 times x minus 1. So now let's take a look at our next set, right? So what is the GCF between in 2a here? Here we have 3. So I'm going to divide everything by 3. So here I've got 3, 3, and 3. So now this becomes 3 times x squared plus 11x plus 10. Go ahead, try this one on your own. Let's see what you get. And here we go. So same thing, right? Let's set this up. So what two numbers multiply to get you 10 and add to get you 11? 10 and 1. So 10 times 1 is 10, but add together get you your 11. So again, 3 times x plus 10 times x plus 1. So now let's take a look at 2b. What is the greatest common factor? Now, we're used to just going, well, Ms. Reiner, let's just divide by 10, right? We've been dividing by that leading coefficient. Well, notice how, can I divide that 55 here? Does that have a factor of 10? No, because it ends in 5. But if I do notice here, I could divide everything by 5. So it's not always going to be that front leading coefficient. So now let's go through. We have our 5 times, but now what's 10 divided by 5? 2. So 2x squared. Then here we've got minus, so 55 divided by 5, so that negative, sorry about that, is 11x. And then here we've got 70 divided by 5, which is going to now give us 14. Now that we've got our GCF, right, and notice how do 2, 11, and 14, do our values have any common factors? No. So we're good. We got our greatest common factor. But notice how a is greater than 1. So we could use, again, box method, or, again, I'm going to focus on bottoms up. So now we go through that process, right, where I multiply. So I've got 5 times. So here we go. We've got x squared minus 11x, but now plus 28, right? Because we multiply that a times c. Now we can factor setting up our table. What two numbers multiply to get you 28 and add to get you, oops, I'm sorry about that. Yeah, add to get you negative 11. Well, we're multiplying again to get a positive, but adding to get a negative. So two negatives, right, when multiplied make a positive. So in this case, negative 7 and negative 4. They would multiply to get you that positive, but add to still get you that negative 11. So this becomes, right, keep that 5, right? Don't let it go because that's the GCF. That's part of your factoring. So I've got x minus 7 times x minus 4. Now, are we done? No, right? Because remember, when we did the bottoms up, we went from 2 to 1. So now what do we have to do? Divide by 2, that leading coefficient. So 5 times, bring the bottoms up. So 2x minus 7. And then x minus 2 from 4 divided by 2. So now let's go ahead and let's take a look at 2c. Here we've got, again, do we have a GCF? Well, yes, we do. Now, I could divide 8 and 12 by 4, but I can't divide 10 by 4. I do notice that all numbers are even, so that means I can divide everything by 2. So let's see if that's the greatest common factor. 2 times, so now I've got 4x squared, right? 8 divided by 2 is 4, minus 5x, because negative 10 divided by 2, and then minus 6 from 12 divided by 2. So now, are there any common factors between our three values? No. So I know that I got that GCF. But because A is still greater than 1, let's go ahead and bottoms up. Let's multiply. So don't forget that GCF of 2, x squared minus 5x minus 24. So here now, let's set up our factoring, right? What two numbers multiply to get you negative 24, but add to get you negative 5? Well, we need a positive and a negative now, right? When multiplying, and we're adding to get a negative. So I could use, let's see, negative 8 and positive 3, right? We also have negative 4, negative 6 and positive 4. But that's only going to give us negative 2. So I know that's not it. Negative 8 plus 3, negative 5. So now I'm going to write it out, set it up, right? X minus 8 times x plus 3. But are we done? No, right? Because of that bottoms up, we went from 4 to 1, divide by 4, that leading coefficient. So don't forget that GCF of 2, then x minus, well, a divided by 2 is, a divided by 4 is 2. Ugh, sorry about that. And then you can't divide evenly, bottoms up for x plus 3. So now I'll go ahead and now let's take a look at these two examples here, because now notice, what are we doing? We are now solving, right? Because we have our equation where it's equal to 0. So here we've got, well, do we have a GCF? Yes, we do. What is the GCF between our three values? 3. So I can divide everything by 3, right? So take out that GCF, and here I've got 9 divided by 3, well, that's 3, so 3x squared minus 4x minus 4 is equal to 0. So now we can continue solving, but by factoring. Notice how a is greater than 1. They have no common factors, so let's go through and let's do our bottoms up. So here we've got 3 times x squared minus 4x, but now minus 12. So now let's go through and continue, but solving by factoring. What two numbers multiply to get us that negative 12c and add to get negative 4? Negative 6 and positive 2. Those two will multiply, but then add to get you your negative 4. So here I've got 3 times, so x minus 6 times x plus 2 is equal to 0. But remember, because we multiplied by that 3, now we need to divide by 3. So 3 times, so now I've got x minus 2 from 6 divided by 3, bottoms up because you can't divide it, 3x plus 2. But now we can solve, right? Because this is equal to 0. So you've got technically 3 terms here. We have 3 is equal to 0, we have x minus 2 is equal to 0, and we have 3x plus 2 is equal to 0. Now, let's take a look at the first one. Will 3 ever equal 0? No. So that really just goes away. We have no x there. 3 will never equal 0. But I do know here that x is equal to 2, right? From solving for x, add the 2 to both sides. So we do have x is equal to 2. And then, of course, solve your 2-step here. Subtract 2 from both sides. So 3x is equal to negative 2. Divide by 3. And you've got x is also equal to negative 2/3. So same thing here. Let's take a look at 3b, right? We're solving an equation. Oh, but what do you notice? It has to equal 0, right? Our quadratic. So what do you have to do first? Subtract the 30 from both sides. Now I've got 2x squared plus 4x minus 70. Now here we go. I notice a is greater than 1, so do we have a GCF? Yes. What is the greatest common factor between our three values here? 2. So I'm going to divide everything by 2, right? So I've got 2, then 2 divided by 2 is 1, so just x squared. 4 divided by 2 is 2, and negative 70 divided by 2, negative 35. Now we can continue solving by factoring. Notice how a is 1, so we can just go straight to the table. What two numbers multiply to get you negative 35 and add to get you 2, right? So again, multiplying to get a negative, so we need a positive and a negative, and they're going to add to get us 2. So let's try, so 7 and negative 5, right? Because that's going to give you 35 or negative 35. When adding, they do give you positive 2. So here I've got x plus 7 times x minus 5 is equal to 0. So now here we can solve. Well, remember, right? 2 is equal to 0. Will that ever be true? No. So we're not going to get an answer from that. But we do have x plus 7 is equal to 0 and x minus 5 is equal to 0. So really, x is equal to negative 7, right? Because we have to subtract 7. And x is equal to positive 5 because here you have to add 5 to both sides to solve, changing that sign. So go ahead and pause the video here and try these 2 U-tries on your own and let's see what you get. And here we go. Notice, right? First step here, our quadratic has to equal 0. So what are you going to do? Subtract 10x. Now see how it has an x? You have to make sure, right, to subtract the like terms. So this is 4x squared minus 24x minus 28 because here you get negative 14 minus 10, negative 24. Now let's factor. Do we have a GCF? Yes, you did. You can divide everything by 4. That is their greatest common factor. So 4 times x squared minus 6x minus 7 after dividing. Now notice how a is just 1, so we can set up our table. Multiply to get you negative 7, add to get you negative 6. You should have gotten negative 7 and positive 1. Those will multiply to get you negative 7 and add to get you negative 6. So here I've got x minus 7 times x plus 1. But is that our final answer? No, right? Because they're equal to 0. Remember the trick, can 4 ever equal 0? No, so it just cancels out. X minus 7 is equal to 0 and x plus 1 is equal to 0. That means x is equal to positive 7 and negative 1 after you solve. From adding 7 here and subtracting 1 here. So now the last one. Do you have a GCF for 3D? Yes. What is that GCF? You should have gotten 5. So I'm going to divide everything by 5. Now let's say maybe you thought it was 15, right? Well, divide everything by 15. You would see that they do not divide evenly. Not all these values divide by 15 evenly. So I'm going to take my 5, and now I've got 3x squared from dividing 15 by 5. Here you should have gotten 14x plus 16 is equal to 0. Now we can continue factoring, but notice how a is still greater than 1, so bottoms up, right? So now I've got x squared plus 14x plus 48. Now that we've got a is equal to 1, set up the table. What numbers multiply to get you 48 and add to get you 14? You should get 8 and 6. Because like let's say 12 and 4, right? But what's 12 plus 4? 16. That's why it doesn't work. But 8 plus 6 will give you 14. So now I've got 5 times x plus 8 times x plus 6 is equal to 0. But remember, because of bottoms up and we multiply by 3, we now need to divide by 3. So here I've got bottoms up, right? Because you can't divide that evenly. 3x plus 8 times x plus 2 from 6 divided by 3 is equal to 0. Now we can solve. See how the 5, right? Will 5 ever equal 0? No, so that just goes away. Here I've got 3x plus 8 is equal to 0 and x plus 2 is equal to 0. So now I notice with this one here, I need to subtract 2 from both sides. So x is equal to negative 2. So I know that automatically my answer was A, because that's the only option that gives you negative 2. But let's also check to make sure that the other answer is the negative 8 divided by 3, or negative 8/3. So solving for x, you subtract 8 from both sides. I've got 3x is equal to negative 8, and then divide by 3. So there's your negative 8/3.